Okay guys, this will be my new copper strip. I will make it from a copper tube, 50mm. I cut off a piece of, 12 centimeters at the moment. And I'm going to take a hacksaw and cut it in two halves. So I have two strips. I will flatten them and I can make them round, and I have a nice solid copper strip. Two things. This is what I'm doing at the moment. Okay, here are my two halves of the copper strip. I have to sand them down a little bit with and I have to flatten them and get them to the correct length. Okay, after flattening them with mild hammering, they look a little bit like this. I have to smooth them a little bit. They are already a little bit curved, so I now have to get the correct curve from the jokes, both sides, and attach them to the joke. Okay, after some extra sawing and filing and measurements, the outer strip is now on the ring, on the joke. So next is the inner ring. Made some markings already, so going to that now. Okay, so after some fiddling and bending and measurements, this is the result. I have two copper plates, one on the inside of the joke and one of the outside. So I have to isolate now them from the joke with some isolation tape, and we'll make some measurements about capacitance first before I join the one side and the inductance. Okay, I have used a colorful black isolation tape to cover the joke, the inside and the outside. And then I have put up the both copper strips. They are not connected yet. They are just fixated with one strip of tape. Now I'm going to measure the capacitance. The meter is not yet hooked up. So I have now something about 12 picofarad, which is when nothing is hooked up, because of some stray capacitance of the wires. Okay, I will hook up one side now. And we'll touch the other one. What is it? And you can see that the capacitance is going from 12 to 22. So this will be 10 picofarad of capacitance, the both strips. I will remove the lead. Better leave it alone, no touching. It's around 12 picofarad. When I touch it, it goes to 22. So the copper strips have a capacitance of 10 picofarad. I will now connect them at one side and measure the inductance. Okay, I have now the two copper strips on both sides. I've taped them in. I made a cross on one side and I put some wires on the other side. So I'm now able to measure the inductance. Inductance meter is at the 2 millihenry scale which is the lowest. I will attach the meter now. And it goes to 4 or 5, which will be micro henries. So there you have it. The copper strips on my joke half are 10 picofarads, but not joined together with the bridge, and they have 5 micro Henry inductance. Hello, okay. Welcome back. I have now put my first coil around the joke. It's the 15 turns. I have the copper strip connected with a cable. I have the bridge on the other side, and I have now hooked up a coil 50 turns. It's wire 1 millimeter thick, AWG 15 I think. And I made some measurements on the lot, and first the data on the copper strip. It's about 1/3 of the height of the joke. It was measured 10 picofarad when not connected to each other. And I have 5 microhenry when connected with the bridge. So that's the data on my copper strip. The first coil, the 15 turns for the 50 Hertz, is measured like this. 15 turns, 15 AWG. It measured 25 microhenries when the jokes are not joined, so only when it's standing like it is now. And when I merged both jokes without any paper, then it's about 160 microhenries. And it self-resonates at around 5.6 megahertz when joined together, and it's 6.18 megahertz when not joined together. Okay, so now we know the data of the coils. I found on the forum this latest procedure from JDO 300, in which he is struggling with the same problems I have. How to properly measure. So he put some procedure together, which is basically okayed by Wesley. Some changements in at point 2. The first steps are to find the core frequency, and you should doing it by pulsing the copper strip and then observing the output on the 15 coil, and adjust the pulse rate between 1 to 2 megahertz to see what ferrite resonant frequency is, and he calls it F core. Well, that's what I'm now going to do first. I have a function generator going up to 2 megahertz. I put in square wave at the moment. I'm at the start of the dial, meaning 1 kilohertz. I have my counter hooked up. It also says 1 kilohertz. And this is how I set it up. I have the function generator hooked up to the copper strips, both sides. It goes to the function generator, and I have hooked up my red probe to the output of the 15 turns coil, which is on the channel 1. And this is what the picture looks like when it's at the lowest frequency, 1 kilohertz. I can already expand this to see what the pulse will look like, and you can see that it already is ringing at this frequency 5.5, which is very close to the resonating, the self-resonating frequency of the L1 coil, which was 6.18 when not connected. It's not exactly, but I think that could be explained by the difference in the setup I'm using now. So I'm going to increase the frequency now with the function generator and see what's going to happen to the pulse if we see some increase. I'm now at 309 something kilohertz. The pulses are getting closer, but still I have a resonance frequency around 5 megahertz. Here we have some kind of triggering resonance or sub-resonance. Just the scope shot. And this is still at 5.4 megahertz, and the frequency counter is now at 7.88 kilohertz. So I still see only, I have another resonance point here. I'm now at 1100, so this would be the fifth harmonic of the counter, or of the wave function generator. I have another nice peak here, resonance peak here. Still at 5.5 megahertz. Frequency is now at 1.8 megahertz. So this would be the third harmonic. And I go now all the way up to the edge of my frequency counter, wave generator. But I do not see any peaks. I just cannot get to the second. So all I can see is a resonance point of the joke in combination with the L1 of around 540, 550, 5.4, 5.5 megahertz. So nothing in the range of 1 to 2 megahertz. Okay, I'm going back to 1 kilohertz now again. Adjust the scope. I have the peaks again. And I will now go to the FFT function, where I can look at the spectrum to see if I can find some better pictures over there. Okay, get at the start of the range. I am now at 50 megahertz per division, so we see a long range spectrum, fairly clean. I will make steps now to 20 megahertz per division, 12, 6. I am now at 3.12 megahertz per division, so the midpoint is 15 megahertz. I'm now going to increase the frequency. I'm not having a clear frequency response now, but I'm going to increase the frequency. Now 25 kilohertz. I'm now at 250, 300 kilohertz, and we see some spectrum coming up, and it's mostly in the range of 6 megahertz, which again is the resonance frequency of the L1 coil. You can see the peaks when I'm continue. I'm now at 700 kilohertz. Okay, I'm now at 1 megahertz. I want to expand the picture to even more, 1.25 megahertz per division. And we see now we have some a nice spike when I tune a little bit. The frequency is now 1 megahertz, slightly more. And this peak in the middle is again at 5.5 megahertz. So this is probably again the resonance frequency of the L1 coil, the 15 turns coil. I can zoom in a little bit, 10 times. .4 again. And we have more frequencies over here. A little spike over here, 4.4 megahertz. Another one here, 3.25 megahertz. Something here, 2.2 megahertz. And I have here a nice spike, is the 1.1 megahertz. But this is where my frequency generator is at the moment. So this is the frequency of my counter. Of my function generator. So also here I do not see any clear evidence of a 1 to 2 megahertz frequency. I can go even lower in frequency range. I'm now at 50 kilohertz per division. Go one back. I have a nice peak over here. This is a 440 kilohertz spike. I'm not sure where it comes from because so here the midpoint is 1.24 megahertz. So I'm not sure where I should find this resonance frequency of the ferrite. It could be any one of those. It's not a distinct peak. I have something here at 1.3. I can tune a little bit, but oops. Counter is now, of the frequency generator is now 2 megahertz. And now see a spike here at 1.4 megahertz, so I'm not sure. This spike is going forward and back when tuning. So I think this is some kind of resonance point or subharmonic. So there is, yeah, I'm not clear how to find this resonant point of my joke. And that's where I am at the moment, and looking for info how to determine it before I can go to the next step. Okay, thank you for now.